Hey geeks and gamers, and welcome back to my channel. Today we're going to take a look at this Intel 11th Gen mini PC and Intel Nuc, and we will combine it with an external graphics card to see how well it performs. Roll the intro. Okay, let's start with a look at the specs and the size of this little device, and then we'll head over to the external enclosure for the graphics card. And yeah, let's do it.
Okay, let's take a look at the size and the specs of this little machine. What we've got here is the tall version of the Intel Nuc with 54mm in height. There's also a flat version, but that one is not able to hold another 2.5-inch SSD or HDD. CPU-wise, we have an Intel 11th Gen i5 CPU, the 1145G7. It features 4 cores and 8 threads with a max turbo of 4.4 GHz, all in a max 28 watts TDP package. With regard to RAM, we can add a maximum of 64 GB of DDR4 memory, but keep in mind that the machine only takes SODIMM. For its small size, the machine features a lot of storage options. You can add a 2.5-inch SSD or HDD, a full-size NVMe M.2 drive, or a short M.2 SATA drive. Our wireless options include Wi-Fi 6 and Bluetooth 5.1. With regard to the rest of the I/O, this machine is nothing short of amazing. We have like 6 USB ports, with 2 USB 3.2 ports at the front, 2 USB 4 Type-C ports at the back. They are basically Thunderbolt. And we have another USB 3.2 and 2.0 at the back. With regard to graphics, we have 2 HDMI 2.0B ports and 2 Intel Ethernet ports featuring like 2.5 gigabits per second. The installation of Windows 11 went super smooth. No problems, no issues. All drivers were detected automatically, and it restarted once and even did like a firmware update. As you can see, I added 16 GB of memory, and we have an NVMe drive, the Corsair Force MP510, featuring 480 GB. Our i5 CPU also features Intel Xe graphics with 80 compute units. The i7 version would have like the full 96 compute units, but that graphics is not meant for gaming anyway.
Alright, with that out of the way, let's take a look at this chunky boy. This is the external enclosure for our GPU, the 3070. Holy shit, it's huge compared to our Intel Nuc, but hey, here we go.
Now let's take a look at our external enclosure from Razer. They are all built very similar. This one has a handle at the back. You swing it open and pull out the whole interior. The inside is very simplistic. You have a power supply with 2 8-pin power connectors and a PCI Express slot on a small board. This is where our GPU goes, our Zotac 3070. Just slot it into the PCI Express slot and add the power cables. That's it. Okay, the power cables can be a bit fiddly if you have fat fingers like I do. Okay, connected via Thunderbolt and back in Windows, the 3070 shows up. Perfect. There's the Intel Xe graphics and there's our 3070. Of course, you should not rely on the drivers Windows chose to install. Head over to Nvidia.com and get the proper drivers, please. Okay, benchmark time. Let's get something out of the way. The external GPU is connected via the Thunderbolt cable, and the monitor is directly plugged into the eGPU, not into the NUC. We would lose even more performance if the signal would have to go back through the Thunderbolt cable and be outputted by the NUC. The Thunderbolt connection surely is a bottleneck in this setup, and we will see that in a moment in the benchmarks. Okay, but first the CPU itself. We start with the Cinebench R23, and of course this video is sped up, but here are the results. we end up with a score of roughly 5,900 points. This is almost beating the i7-7700K, a 90 watt TDP CPU with a max boost of 4.5 GHz. Not too bad for this small Intel Nuc. This machine should be fine for some light workloads, video editing or photo editing. Now for the graphics benchmarks. As you can see, TimeSpy was not very happy with an external GPU. You have a little exclamation mark on the top left corner. But otherwise we score 11,600 points. You should get roughly 13,500 normally, but we are bottlenecking hard with that CPU and the bottleneck from the Thunderbolt. PCI Express is so much faster. Okay, what about some real games? Let's start with Shadow of the Tomb Raider at the highest preset and see how it runs. Okay, we end up with an average of 74 FPS. With an i5-11400F, we should get with that card roughly about 100 something FPS, so we are losing out on 30% of the performance. And let me show you something really interesting. The bottleneck from the Thunderbolt connection is real. Check out the following clip where you can clearly see assets popping in and textures. Check this out. Bam! Now it happened. This is due to the limited bandwidth of the Thunderbolt 3 connection. Now for one of my favorite benchmarks and games. Wolfenstein Youngblood. It's set to the quality preset Mein Leben. RTX is on and DLSS is on. Here we go. Although the result looks really good, we still lose like 30% of performance or 40%. Of course, this is in comparison to a normal PC where you plug in the graphics card into the PCI Express slot. Next up is F1 2020. This should be an easy to run title, right? Let's see the results. We average out on 129 FPS. As I had benchmarked this card already in my kid's PC, featuring a 10700 i7 CPU, I can tell you that that CPU and that card managed to reach an average of almost 230 FPS. Okay, let's go with something easy to run. Really easy. Far Cry 6 on the Ultra preset. Yes, let's do it. And here are the results. We end up with an average of 77 FPS. We should end up with around 100 FPS, so once again we lost like 30% of GPU performance here. Okay, time to test a more recent title, Assassin's Creed Valhalla. With regard to the result, it's totally playable, but we are heavily limited by the CPU here on the ultra high preset. I guess a lot of stuff is going on in the scenes, so let's run it again at a more medium preset. Okay, I went with a high preset in the end, and here are the results. This looks much better and totally playable. Nice. This is better than I expected, honestly. Conclusion time. As I was down with the flu for some days, I'm not in front of the camera for the conclusion, but just listen to me. The Intel Barebone Nuc comes at a price of around $500. For that money, you can easily build an ITX system with a mainboard CPU. You still need to add RAM and storage, but you also need to do that for the Intel Nuc. And don't forget about the price for an eGPU case. You need to buy that one, of course, too. Performance-wise, you're leaving a lot of the performance of the 3070 on the ground. You lose like 20 to 30% easily compared to having the card in a regular PC system. The bottleneck from the Thunderbolt connection also is real, and normally that is not an issue that you never notice, but in that one case of Tomb Raider, you could see the assets and textures popping in, which is a bit sad because no other game or program did that. So, who is this solution for? Who wants to plug in an eGPU? Basically, if you already own an Intel Nuc or a similar system that provides you with a Thunderbolt port, this is an easy solution to get a gaming PC. You just have to be aware of some limitations and that you'll lose some performance. Everyone else? Honestly, just build a regular PC. It's easier to upgrade and maintain, and you don't lose any performance. Okay, that's it for today. Thanks for watching. Don't forget to like, subscribe, and ring that bell, and I'll see you in the next one. Alpha, over and out.